Welcome to the lecture of data science. In this video, we will see the outlier analysis, the confidence interval and the prediction interval. These topics from unit number 5, that is the simple linear regression. So let's start with the outlier analysis. So what are the outliers that we have already seen in our previous lecture? So outliers are the observations whose values show a large deviation from the mean value. So suppose these are my different outliers. If I take out the mean value of all these outliers, then that particular mean and this particular data point is very far from the mean. So it is called as the outlier. So the outlier analysis, where it is used for the different types of data set, whether it is the graphical data set, whether it is the numerical data set, whether it is the text data set, or whether it is the pictures data set. So the identification of outliers can lead to the discovery of useful and the meaningful knowledge. So the outlier analysis is very important because it gives us some information, it will give us some knowledge. So how to find the outliers from your data set? So these are the following different measures available for the outliers. So the first one is the z-score, then comes the Mahalanobis distance, then comes the Cook's distance, leverage values, and df beta and df fit values. So we will see turn by turn everything. So let's start with the first one, that is the z-score. So what is the z-score? It is the standardized distance of an observation from its mean value. So just for an example, this is my formula of the z-score, that is x, that is my particular data point, its values, that is the x minus mean divided by the standard deviation. So if I do this, then I will get the z-score of a particular point. So let's understand in detail. So suppose this is my graph, and this my graph shows the normal distribution because it has the bell shaped. Now where my mean lies in my normal distribution, so in the unit number 2 in the phase 1 we have seen that where the mean lies for the symmetrical bell shaped curve. So where it lies somewhere over here in the middle. So this is my mean value that you can see over here, that this is my mean value. Now I can find out the standard deviation by using the values from the different data points. So using that distance of the standard deviation, I have drawn one vertical line over here. So this distance is the distance of my standard deviation, and I have drawn one vertical line on the left hand side, one vertical line on the right hand side. So you can see that this is my first standard deviation. Then again with the distance, I am drawing the second vertical line. So on the left and the right hand side both. So this will be my second standard deviation, and with the same distance, I will draw one third vertical line. That is my third standard deviation on the left hand side and on the right hand side, both the sides. Now what the normal distribution is showing, so what information we are getting from such type of graph. So let's see that. So if I consider the area between the first standard deviation, that is this one and this one, then these are the areas which is covered between these two lines. So these are the areas which is covered between the first standard deviation. So I can tell that from this that the 68% of the data point lies between my this particular range. So you can see this is my complete data set, and in my this particular data set, suppose I am considering this data set as the 100%, then this particular highlighted portion is only the 68% of my data set. If I take the values like this, that is including this particular range, that is from second standard deviation to second standard deviation on both the sides, then this particular complete area, that all this blue highlighted line, it shows my 95% of the data points lies in this particular range. Now if I consider this particular range, that is from third standard deviation to third standard deviation, then my this particular area covers the 99.7% of my data points. So only few data points are there on this particular side, that is outside the standard deviation on left hand side and on the right hand side like this. So whichever data points are there which is beyond this particular third standard deviation, that I will call it as my outliers, because my majority of the data points falls over here, that is in my highlighted portion of the blue. So whatever data point is far from this all the three standard deviation, so that data point will be considered as the outlier because it is very far. So whether the point is far or it is near, so you can calculate like this. So if my point is somewhere over here, just for an example, so if my data point is somewhere over here, that is this particular red circle, or somewhere over here on the right hand side, that is this particular red circle, then I will call it as the outlier because this particular distance is very far from this particular mean. So you can see the distance, that it is very far from the mean. So what the z-score is telling, that if the data point is very far from the mean, then it can be calculated as the outliers. Now let's see one example with the definition that if the z-score of a data point is more than 3, then it indicates that the data point is quite different from the other data points. So such a data point can be considered as the outlier. When it is considered as the outlier, when the z-score of a data point, its value is more than 3, then we can consider it as the outlier. So this is one of the examples. So this type of example can be asked in MCQ also. That is just for an example. In a survey, it is asked that how many children a person had. So the data is obtained from different people, and you can see over here that someone is telling that someone is having one children, someone is telling they are having two children, then two children, someone is having three children, and like this. So someone is telling that they have 15 children. So my all the data point is between 1 to 3, but this 15 is quite different from my other data point. So this my 15 is considered as an outlier in my this particular data set. The next one is the Mahalanobis distance. So what the Mahalanobis distance is telling, that it is the distance between the specific value of the independent variable, that is xi, to the centroid of all the observations of an explanatory variable. So just observe this definition very carefully, that we are talking about the x variable only. We are considering a specific value of the x variable, that is xi, whether it is x1, x2, or whether it is x3 or up to xn. And we are considering all the observations of the x. Explanatory variable means we are talking about the x variable only. So we are considering a particular x point to the centroid of all the observations of that particular x point. So let's see this with the help of a graph. So this particular, all the blue points shows my x data points. So this is my centroid, or we can say the center point of my all the x data points. So if I consider this particular blue point, which is shown with the help of the green cross mark, then this particular data point is comparatively near to this particular data point. So I can say that my this particular data point is within the cloud. So my this particular data point, that is the green mark, is not considered as an outlier. This data point is far from the centroid, so I can say that this particular data point is can be considered as the outlier according to the Mahalanobis distance. So the z-score is focusing on the mean value, whether the point is far from the mean or not. Over here in the Mahalanobis distance, they are calculating the centroid of all the observations. So whether a particular point is far from the centroid or not. So like this, the Mahalanobis distance is calculated. Now next one is the Cook's distance. So the Cook distance measures how much the predicted value of an independent variable changes for all the observations in the sample when a particular observation is excluded from the sample for the estimation of regression parameters. So this is my Cook's distance. So just for an example, that I have one regression line like this. Now if I remove one particular point, So suppose I'm excluding this particular point. Suppose this is my outlier. So my regression line can be like this. That is, instead of this particular position, my regression will be at this particular position that I have drawn with the help of the red line. So if I exclude a particular point from my data set, then what is the impact in the regression line? Whether its coefficient will change or not. That is, my intercept and the slope will change or not. So this is what the Cook's distance is telling about the outliers. So next one is the leverage value. So the leverage value is an observation which measures the influence of a observation on the overall fit of the regression function. So if I consider a particular data point, then this particular data point, how greatly it affects my this particular regression line. So if I remove this or if I does not remove, then it makes no difference to the regression line. So whether a particular data point is impacting your final regression function or not. So this is what the leverage value is telling us. The last one is the DF fit and the DF beta in the outlier analysis. So what the DF fit is telling, that DF fit is the change in the predicted value, that is the yi, when case I is removed from the data set. So when I remove a complete row from my data set, then what will be the change in the predicted value? Uh, that is what the DF fit is telling. What is the DF beta? It is the change in a regression coefficient values when an observation I is removed from the data. So DF beta is focusing on the regression coefficient, whereas the DF fit is focusing on the predicted value of the yi. In both the cases, we are removing a particular row, that is the row with index position as I. The next one is the confidence interval for the regression coefficients. So now we will see the confidence interval and the prediction interval. So we have to see that what the confidence interval is. So suppose this is my data set, that is my fuel consumption comp. So on this data set, we have implemented the simple linear regression model. Now, just for an example, this data set contains how many rows? This data set contains 1068 rows. So just for an example, that this particular data set is of a particular car company. So suppose I'm taking that this data set is of the Maruti Suzuki company. Then it shows me the values of the CO2 emissions. Then what is the values of the CO2 emissions in this particular data set? Then you can visualize that my value starts from 108, that is my minimum value is 108 and my maximum value of the CO2 emission is 488. Now if I consider that this particular data set, it is the data set of only one company, so I'm telling that this my particular data set I'm considering as the sample data set. So I'm considering it as the sample, and the population data set I'm considering as the data set of all the car companies. So I want to predict that what will be the CO2 emissions of all the cars which are from the different companies. So based on this sample data set, I am considering this Maruti Suzuki data set as my sample data set. So in my sample data set, I have the value of the CO2 emissions from 108 to 488. So I can predict that in all different cars from all different companies, I have the CO2 emissions in the range of 0 to 500 like this. So what I am doing, based on the sample data set, I am predicting the complete interval of CO2 emissions of the population data set. Again, I am repeating, this is my Maruti Suzuki data set, suppose. So I am considering this data set as my sample data set. In my sample data set, I have the value of CO2 emissions from 108 to 488 like this. Now, based on this sample data set, I have visualized every values of the CO2 emissions. So from the sample data set, I am predicting the interval, that is the CO2 emission value interval of the population data set, that is the car from all the companies. So I am writing that my CO2 emission will fall under 100 to 500. Its value will not be 1500 like this because it is very large value. So my, for all the car companies, my value will be in between 100 to 500. So this is what we are calling it as the confidence interval. So this is how the confidence interval it is working. So the interval estimate, that is the 100% confidence interval for the coefficient, that is the beta 0 and beta 1, it is given by such formula. And the confidence interval of the expected value of the yi for a given value of x, it is given like this with the standard error formula. Now the next one is the prediction interval. Now what the prediction interval is, it is somewhat different from the confidence interval. So over here we are predicting the value of the yi, that is my yi value for a given value of xi. So how this prediction interval is different from the confidence interval? In the confidence interval we are telling the range in which my complete data points will lie. Over here in the prediction interval, we are predicting a particular value of y for a given value of x. So in which range my particular value y will fall for my particular value of x. So it is called as the prediction interval. So again it is the range. So it is a range given like this. So you can find the plus and minus symbol in that because we have to give the complete interval. So with the standard error formula. So this is what about the simple linear regression model is. So thank you for watching.